So, good afternoon, guys. So, today, me and Ayush will be presenting a session on data pre-processing and the steps involved in it. Okay, so the data pre-processing, why do we need data pre-processing, and what is the need for that? All the other things we are going to discuss. Before that, these are some of the knowledge etiquettes that we need to have in mind. That first thing is that we all should be punctual. We should provide the you should please provide with the required feedback, and please keep all your devices in silent mode, and avoid any disturbance. Now, for the session, what are the agenda for our discussions? That what and why data preprocessing is required. Then, inside data preprocessing, we have a submodule. We have a subtopic: data cleaning. Then, what is data integration, data transformations, data reductions, and after that, we will be having a working demo, the Python code that will be showing you how we are doing the data cleaning. So first thing, what is a data cleaning service and why do we need a data cleaning service? Prior to that, there was a demo that was being conducted on data scientists to see what is on which part of the work they spend their most of their time. So you can see that while building the training data set, they spend only 3% of their time. Collecting data sets, they are spending 19% of their time. Mining the data in order to get some patterns or anything like that, they are spending 9% of time. In order to define some algorithms, they are spending 4% of their time. And in other some small works might be deployment or anything like that, they are spending 5% of their time. But the majority of the time, that is the 60% of their time, they are spending on cleaning and organizing the data. So you can see, being a data scientist or being a machine learning engineer or any data analyst who need to work upon a data, you can see the most of our time are being spent on cleaning and organizing the data. So data cleaning is considered to be one of the most underrated but the important aspect that the data scientist or a data analyst should be aware of. And why do we need data cleaning service? It is been told that good data preparation is the key to produce valid and reliable models. Models, what kind of models? We are talking about machine learning models, the models that we develop using some of the ML or the machine learning algorithms. So now I think most of the people won't be even aware of what is machine learning. So before talking about models, let's just talk about what is machine learning. Okay. So according to the author Samuel 1959, machine learning algorithms enables the computers to learn from data and even improve themselves without being explicitly programmed. So what do you mean by that? We mean by that, earlier what was happening, we have a program, we run the program, we get an output. Okay. Now what we are doing, we have an input, we have output, and we have an algorithm, and we want the algorithm to decide that what pattern should be followed or what kind of uh, training should be done, so that my algorithm decides that if I am getting this size set of input, then what kind of output should be, if I am getting this such set of input and this set of output, so which type of programming or which type of logic to be developed. That is the work of the machine learning. Earlier we were having input, output, input program, and we are getting the output. Now we are having input, output, and in the intermediate layer we are having algorithms. Okay. So machine learning is a category of an algorithm that allows the software application to become more accurate in predicting outcomes. That because we want the outcomes. Okay. The basis premise of machine learning is to build algorithms that can receive input data. Like I told, we want the input data and use statistical analysis. So one thing is the most important that we all should be aware of the fact that in machine learning, the main use is of mathematics, and inside the mathematics, the main use of statistics always. Okay. To statistical analysis to predict an output while updating the outputs as new data becomes available. Okay. Now, types of machine learning. So there are actually three types of machine learning: unsupervised learning, supervised learning, and reinforcement learning. So what do you mean by unsupervised or supervised learning? Like you can say this is just an image to show that we know the output. Like over here, this is a depiction from Mahabharata, where Guru Dronacharya is asking Arjun to hit the eye of the bird. So he knows what is his outputs, and he is moving according to that. This is supervised learning, like you are aware of your output and what you need to do. Then what is unsupervised learning? Over here you can see there is a man, he don't know what he need to do with he don't have any kind of output, and is not aware of the process that need to be done. So inside unsupervised learning, what are the different things that we do inside unsupervised learning? Either we do clustering or we do the dimensional reduction, because we are not aware of our outputs. So we are segregating the outputs. But inside the supervised learning, we are already aware of the outputs. So we apply different kind of algorithm. One of there is a regression algorithm, and then the other one is a classification algorithm. Okay. So now this is a total life cycle in a machine learning, that we are getting a data set. Then we have a data cleaning operation. This is the operation, or this is the phase that we will be talking about. Okay. So after getting a data set, the first operation that we do is the data cleaning operations. Okay. After that, we are having feature engineering. What do you mean by feature engineering? Like we are getting a data set, and inside that data set, we might have a large number of features. Feature refers to the columns, you can say, or the attributes that are required in order to get an output. So feature engineering means that which columns are necessaries, which columns are not necessaries, how much are those columns or attributes correlated, and which should we use, which should not be used. All these things comes under the feature engineering. Then we have a training data. We have a then we split our data into two halves. One is the training data that is used in order to train our machine learning algorithm. This is a learning algorithm. Then we are training our model based upon the different kinds of machine learning algorithm. Then out of our feature engine only, we are dividing our training data to a new data, or you can call it as a test data as well. In this test data is required for evaluation of our model, that how our model is performing. It should not be the case that our model is performing well on the training data, but is performing bad for the test data. So over here, this part of data cleaning and feature engineering comes under data pre-processing. Okay, or so what is data pre-processing? So data pre-processing is an important step in machine learning. The phrase garbage in and garbage out is particularly applicable to data. This is the process of transforming raw data into useful, understandable format. Real world or raw data has inconsistent formatting, human errors, and all. So our data can be incomplete and all. Data pre-processing involves resolve such issues and make the data sets to be more complete. There can be some issues where we are getting some incorrect data, or because of human errors, or might be because of the faulty machines and all. So those things can be so data pre-processing resolves such issues, and it is one of the most crucial process that I have told you that affect the success of data mining and machine learning projects. It makes the knowledge discovery from data sets faster, because if you have a right data, then you can have more knowledge discovery from the data sets, and ultimately this only affect the performance of machine learning models. So you can have a look over here, that this is how we are getting the data in our real world. Okay, it might look that the data scientists or the machine learning are getting the right getting good data. It's not that case. Okay, this is how we are getting the data, and it's our task to do a data cleaning operation. And this is how we store our data. Like these are just a typical example of a person handling wires, and among this data we are creating our machine learning models. Now, why data pre-processing is necessary? So I have told you that data in the real world is dirty, it's incomplete. So there might be some missing attribute value, or lack of certain attributes of interest, or contain only aggregate data. For example, let us say we have a column, or we have a column named department, and the department column is empty. Okay, so this is one incomplete data. Other is noisy data. So what do you mean by noisy data? So sometimes there are some columns which contains errors, or they contain sometimes like outliers. What is outliers? We will discuss later. But they contain certain kind of errors. For example, age is in negative number, or you can say salary is in negative number. So we know that this is not possible. So these are some of the noisy data. Okay, they have some value. Like over here, you can see we are missing a value. They have some value, but the value is of no use, you can say, or the values itself wrong over there. Or else we have some inconsistent data. So what do you mean by there is some discrepancies between the codes or the names? For example, we had two column in a data set. One column is age column and the other column is the birthday column. Okay. So you can have a look that the date of birth of the person is 27/0 to 1997. So if according to that you will calculate the age of the person, it will be 25 as per now. But what we are getting the age is 42. Okay, so this is some kind of inconsistent data. This can also happen with us. So these mistakes, the above mistakes that I have discussed about, that if the data is incomplete or the data is noisy or the data is inconsistent, this mistakes or redundancy, missense values and inconsistency compromise the integrity of the set, like the integrity of our data set that we are. And these are all the problems that can help, that can make our machine learning model more inaccurate. Okay, so what is our task? So our task is to fix all this kind of issue and for a better outcome. Okay, and chances are that the system will develop biases, like if we are not doing, if we are not considering these mistakes, or and we are directly working upon the data, so there might be a chance that the system will develop some biases and the system may develop some deviation, and this deviation and biases will produce a poor user performance. So how we can judge whether our machine learning model that we have created is good or not? So there are three things. So this or small dots that we are seeing are actually the data points. Okay, and over here you can see a case that the machine learning model is able to read all of the data. Now we might be thinking, and this is good, but this is not good. Actually, it is a high variance data. Okay, so what do you mean by high variance data? This data would be working very fine on your training data, but it might fail when we are given it a new set of data or a new series of data that we use to test data or the real world data. Then our machine learning model might fail. So this is one case of overfitting that we don't want, that our model should not be a overfitted model. The other case is the underfitted data, underfitting case. Over here we can see that we are having a high bias, right? We are having a machine learning model, we have created a model, and this is the prediction of the model. You can see this straight line is nothing but the prediction of the model. And over here you can see that we are having different points. These points are segregated out, but there is only a straight line passing through these points, and it's only able to predict 1, 2, 3 or 4 points. Okay, and the errors rating over here will be high. So this is a case of underfitting. It refers to the fact that even you're not able to predict the correct output of your training data as well. So what is a good balance? The good balance is the case when we have a low bias and low variance. Okay. So low variance refers to the fact that it works best for your training data as well as it works best for your test data as well. Okay. Now, before understanding, before cleaning of the data, also there is one more topic that should always be in our mind. That is data understanding. Okay, so the data set that you have got, or like it can be a data set of an e-commerce industry, it can be a data set related to a medical industry. Okay, so we should be aware of the domain also, that what is the relevance of some data. Like in e-commerce industry, if you're getting, and if you're and you are at that point of time, you will be dealing with transactions. In medical, in if you are working for any medical company, or if you have got some pharmaceutical data, at that time, at that point of time, you won't be working with transaction. You would be mostly working with descriptions. Okay, because every time you would be getting some, there would be a medicine name, and along with the medicine, you might be getting that what are the benefits of using that medicine, what are the side effects of using that medicines and all. So you would be knowing the life cycle of a medicine, rather than the way we are having the e-commerce data. The same way, if you are having a data from a flight system, like if you are like once I was working in a project where we're having a data from a flight sensor. Okay, so that was too much amount of data. Okay, so we should be aware of the fact what data that we are getting, what is the need for that data, how much data is applicable. Like for the flight sensor data, it was that the sensor was producing data in every millisecond. So we don't require the data at every millisecond for a flight sensor. But at the meantime, we are working with the bank data or bank transactions data. At that point of time, we should be aware of that we need data at every millisecond, because we don't want any transaction to fail. And if any of the transaction is failing as well, we want that we should have a proper log for that. Okay, So at first, before cleaning of the data, we should have a data understanding, because this understanding will only help us to know which columns are necessary, which columns are not necessary, which values to be filled on those columns. If there is a missing value, which value we can fill also. Those understanding would come from the domain knowledge or from the data understanding that we are seeing. So what data is available for the tasks? Is the data relevant? Is additional relevant data available? If for example, if you are having very less amount of data and you want more data in order to make your machine learning model more robust, then is the additional data relevant? And how much historical data is available? Because we all know that machine learning or any kind of algorithm design would be based upon the analysis, and analysis is already done on the historical data. So how much is the historical data available? So these are the various steps in data pre-processing. One is the data cleaning that we would be discussing. Then we have a data integration, data transformation, data reduction, and data discretization. Same, same as subsampling of data. Okay, so this is an image that just to show you that we have a dirty data. We need water to clean our dirty data. Like we have, our data is been cleaned. Then we have a data integration. So we are getting a data from different kinds, and we are getting a single data. We're creating a single cube of data. Then data transformation, like for example, this we are seeing in absolute number minus 23200 and all, and we are just dividing into standard formats. We are doing the standardization of this particular data. And then we have a step of data reduction. Over here we can see that we are having different columns, different rows and different columns, and we are just taking that like it is having 2000 rows and 126 columns, but we are only working upon 1456 rows. The rows with the number of records that we need, and the number of columns is 115. We drop all those columns which are not needed by us. Okay. So data cleaning, or cleansing operation is the process of cleaning the data set for missing values, removing outliers, correctly inconsistent data points, and smoothing the noisy data. In essence, the motive behind the cleaning is to offer complete and accurate samples for machine learning models. Okay, so I have told you earlier also that we just want to make our machine learning model robust. So some effective data cleaning techniques is either we need to remove the duplicates. First of all, if you have any duplicate row and if you want to remove it, so first thing we should search for the duplicates. Before searching a machine value, search for duplicates. Why? Because duplicate entries are problematic for future reasons. First of all, when an entry appears more than once, it receives a disproportionate weight during training. So it can be happening that if you are training a model, and along with training a model, there is two things that are being trained, that is a weight and biases. So if if we have a duplicate record, then we may receive a disproportionate weight. Okay, thus the model that succeed on frequent entries will look they perform well. Some of the time they will look that they perform well, while in reality this is not the case. Then if we have some irrelevant data, like data often comes from multiple sources, and there is a significant probability that the given table or the database includes entries and they do not really belong for our use case. Like the way I have told you that it's not necessarily all the columns that you are got taken or all the rows that you are having would be relevant for you. So we will drop those things which are not relevant for you. For example, if there is a unique column known as ID that was a primary key that we got from a table, and there is no use case for us for that particular sequential increase in primary key or our GeoID column. So we could remove this irrelevant data. Okay. In some cases, filtering out the outdated entries. If the data is if there is some outdated data and all, so we can filter out those. Then if there is some errors, so if there is some errors, some syntactical errors, not syntactical, some grammar errors or anything like that, so spelling mistake or extra punctuation marks in the data, like if it is a wrong email address and all, we can fetch those. Then we have a handle missing values. So missing data is defined as the values or the data that is not stored. So what do you mean by missing values? So you can see that over here we have a student ID, math and English. Okay, these are the two columns, and one there is one student ID, and we can see that these are the rows. These are the rows for which the values are missing. So missing does not refer to the fact it will be empty. You can have a NaN value. You can have some value that is not appropriate. Okay, like over the mass you're having X or 99999. We know that it's not appropriate, or question mark, anything like that. Okay, so these are the missing data. So So missing data defined as a values or data that is not stored or not present. Okay. Now we have one more, noisy data. So what are noisy data? So noisy data are the random error or variance in a measure value. So if we are getting some kind of random errors, like you can see that these are the data that we plotted our data on XY axis. This is our total data set, but there are two data points. This is the total data points, and these are there are two data points which are totally separate out from our data points. Okay, so these are known as outliers. Okay, some values that is not consistent with all the other values that are present in our data set. Okay, so incurrent attribute values, and what can be the reason? There can be many reasons. First reason is the faulty data collection instruments. Our data collection instruments is faulty, or we have some data entry problems. There can be some data transmission problems, or if there is some technology limitation, or if there is some inconsistency in naming convention, then we can have this issue. Then how to handle that? For example, if we want to handle the missing data, first is that just the data that are missing, just ignore all those rows. This is where this can be one way, but no. If we will follow that way, then there can be a loss of information. So we need to find a way how we can fill those missing data. So either we can fill it manually. Okay, so if there are 10 rows or 20 rows, we can think of filling it manually. But what about we are having 10,000 rows or 10 lakh rows? So it is not feasible for us to fill it. It's very tedious and infeasible for us to fill those. Okay, so what we will want to fill it automatically. So how I can fill it? Either we will introduce a global constant, but the problem with the global constant will be like a single value for all those missing value. It can be zero or anything like that, but what should be the value, and is that value appropriate or not? Okay, so that is the issue with global constant. Then what else we can do? We can do some kind of imputation. Okay, so what we can do, we can find mean, we can find the median, or we can find the mode of the data to fill in the missing value. So if we're using a normal distribution, then we can find the mean. If we're using not, if our distribution is not normal, then we can move forward with median. And if the case that our data is not is we can try for mode as well, if we are having a non-normal distribution. Okay, that mode one is only the most probable value. So use the most probable value to fill in the missing value. Now, since we talked about the missing data, how can we handle the noisy data? So in order to handle the noisy data or the outliers, the first method that is being done is the binning method. Okay, so binning method is used to smooth data or to handle the noisy data. In this method, data is first sorted. We are sorting our data. Then the sorted values are distributed into a number of buckets. So we are first sorting our data, and then we are dividing our data into small buckets. This buckets is only known as beans. So this the name of the method is binning method. Okay. As binning method consult the neighborhood of values, they perform the local smoothing. Okay, because the binning methods depends upon the other values that are present. So they perform the local smoothing. So three kinds of smoothing are: first is smoothing by bean, means by the means. So in smoothing by mean means each value in the bean is replaced by the mean value. Okay, then we have smoothing by bean median. So in this method, each value is replaced by the median value, by the bean's median value. Then we have smoothing by bin boundary. In smoothing by bin boundaries, the minimum and the maximum values in a given bin are identified as bin boundary. So if you're having a data, the minimum and the maximum are identified as the bin boundaries, and each bin value is then replaced by the closest boundary value. So for example, let us say this is the data that we are having for some price data. So this data has been sorted in ascending order, you can see, and then we are divided into three bins. Bin 1 is considered 4, 8, 9, 15. Bin 2 is 21, 21, 24, 25, and bin 3 is 26, 28, 29, 34. So now we are doing smoothing by bin means. So what do you mean by mean? So we are finding the mean for each bin. So for this bin, the mean is 9. So the value of bin 1 will be 9999. For the bin 2, the mean is 23. So the value of the bin 2 will be 2323. And for the bin 3, the value is 29. So the value of the bin 3 will be 29. Now we are having smoothing by bin boundaries. At goal by boundaries, they will find a maximum. The maximum is 4, minimum is 15. And we can say that the 4 is closer to 4. So the value is 4. 8 is closer to 4 to the value rather than 15. It's closer to 4, so the value is 4. 9 is closer to 4 rather than 15, so the value is 4, and 15 and 15. Same we can say for bin 2 as well. uh, the value is 21, closer to 21. The minimum is 21, maximum is 25. The value is 21, so it is 21. 24 is closer to 25, so 25 and 25. Same is the case with bin 3. 26 and 34 are the boundary values. So 26, 26, 28 is closer to 26, 29 is closer to 26, and 34. So this is the one of the binning methods how we can handle the noisy data. There are other two methods. One is the regression. We can even do the regression, or we can do the clustering in order to combine the similar data. That will be discussion in, later. Okay. So now I would ask Ayush like to present, and he will be explaining about data integration and the other. Ayush, over to you.
Yeah. Thank you, Neeraj, for explaining the prior points. I hope my screen is visible to all. And let's continue with the next points. So, what is data integration? So this is the next steps that comes in the data preprocessing stage. So, what is data integration? It is basically what it does is it combines data from multiple sources, which are stored in various technologies, and provides a unified view of the data. So suppose we have two CSV files, and both CSV files contains the same data, and they are stored in multiple cloud locations. So we can combine those data to make one simpler data, and then perform our ML experiments on that data. So what are some issues that can arise from the data integration part is that when we are integrating from different sources, there could be an issue such as the column names, or it might be different. Let me explain you as with an example. Like suppose in one CSV file, the column name is there is a column name called salary, but in the other one it is mentioned as income. So these two column names are different, are named different, but they are basically actually containing the same values. So here we have to basically verify and check and resolve these type of issues and the conflicts that are arising. And one of the other conflicts that could arise is like the metrics is different. Suppose the income in one section is mentioned in dollars, while in other is mentioned in rupees. So as you can see, there could be various discrepancies caused due to this, and how this will ruin our ML model, right? And then there is last feature. Then there is last thing, removing duplicates and redundant data. As Neeraj has explained prior, why we should remove duplicates data and redundant data, so that basically our models perform better, and the weightage provided to those duplicate models should not rise high, so that our models perform accurately. Let's move on to the next section. Data, what is data transformation? Now here, with data cleaning, we have already begun to modify our data, but data transformation process is basically turning the data into proper format. Now, one of the main methods to check that we need to perform data transformation is the aggregation method. So what is data aggregation? Data aggregation is the process where data is collected and presented in a summarized format for a statistical analysis. This process is like finding sum, average, max, and min. So what can these things tell us? Like suppose, let's take the example of max and min. So if you observe that the maximum value of a data is rising to really high boundary, suppose this example 5,000, and you know that in no scenario it could reach that. So it can tell you that these just it can tell you that the data that you are using contains outliers, that that is the range why the 5,000 data is coming. And suppose if there is a range called 10, like these type of values are indicated in minimum value, so you can still say that these values should not be present here. So in this way, it will help us to summarize and see like what we could enhance and perform more. So we can choose to perform the binning methods, as Neeraj has told earlier, again, and see what improvements can we make. Second is feature scaling. So feature scaling is a technique to standardize the independent features present in the data into a fixed range. Suppose suppose there is a column that there is a feature that ranges from 1 to 10, and there is another feature that ranges from 1 to 1000. So now, as you can see, when we feed these models to our training process, when our model is the the feature that contains 1 to 1000 weightage, 1 to 1000 data will basically get more weight, and it will create biases, and due to this our ML model will be skewed. So to resolve this issue, we perform feature scaling. So feature scaling can involve multiple techniques. One of the technique is called min max scaler. So like suppose there is a data that is 1 to 10 range and 1 to 50 range, we can basically by using min max scaler we can scale it down to 0 to 1 ratio. So by this we will be able to get a simpler scale, and the scale that is common to all. Now the other method is normalization. So what is data normalization? Data normalization is the method of organizing data to appear similar across all records and fields. So it is basically similar to scaling, but when do we use it? So basically in this technique, we also rescale our each row of data to the length of one, and it should not be greater than one. And so this is useful when our data set contains a large number of zeros. When we perform this type of normalization on a data set that contains large number of zeros, we basically get higher quality models after performing this normalization. So there are two types of normalization. First is L1 normalization. It is defined as a normalization technique that modifies the data set values in a way that each row, the sum of the absolute values will be always add up to one. So basically what it does is like after applying this L1 normalization, all the values, when you sum it up, all the values will be adding up to one value. So as you can see, the scale has been balanced between 0 to 1 ratio. So it is also known as the least of absolute deviations. And the second one is L2 normalization. So it is defined as a normalization technique that modifies the dataset values in a way that each row, the sum of the squares will always add up to one, basically. So here in the same way, in L1 normalization, will be adding the absolute values. In here we will be adding the sum of the squares of those values, and they will always add up to one. So it is also called the least squares method. And one of the major benefit of using L2 normalization, it basically penalizes the large weights. So the data points that are repeating again and again, it basically penalizes them, and helps them to tone it down and provide a lesser number to them. Now let's move on to the last method, that is feature selection. So feature selection I'll be discussing in the next slide too. So feature selection is a method of reducing the input variable to the model by using relevant data. So basically, suppose a data set contains 30 features, but there are many features that are highly correlated. So what you can do is you can tone it down to 2 or 3 features because of the high correlation, and then on the basis of those 2 features, your model will be able to perform way better rather than using 30 features. So what are some benefits of using feature selection? Is performing feature selection before data modeling will reduce overfitting, so that as Neeraj have told, what is overfitting? It basically results in high biases. So let's and the second point is performing feature selection before data modeling will increase the accuracy of model. So as I've told you, if we are testing our ML model on 30 features in comparison to two features, the better model will be of the 2 features. Now, the third point is performing feature selection before data modeling will reduce the training time. So as you can see, when we train 30 different features, our model will definitely take higher number of time. And when we train on 2 or 3 model, or whatever you decide, our model training time will be reduced. So that will help us to do more things. Now the last point is data reduction. Data reduction or dimensionality reduction, basically it is also known as dimensionality reduction. It basically helps to reduce the number of features or input variable in a data set. So one of the methods that I have discussed earlier is like reducing the 30 features down to 2 features. Like so basically the number of features or the input variable of the data set is basically called the dimensionality. And the other thing is, the higher number of features, the so as I've told you, with the high number of features, it will be troublesome to visualize the data, and it will be training time will increase, and our model accuracy will drop. And when do we perform data reduction? Is basically when we are sure that that the columns are highly correlated with each other. So one of the so there are few strategies involved in data reduction, or we can say dimensionality reduction techniques. So the first is PCA. What is so PCA is also known as principal component analysis. So, so PCA is a dimensionality reduction method that is often used to reduce the dimensionality of the large data set by transforming a large a large set of variables into a smaller one that still contains the most information of the larger data set. So we will see it further how it works in our demo session. But in a simple scenario, we can say when if there are 30, you have 30 features and they are highly correlated, you can basically reduce it down to two. So because they are highly correlated, they will still those two features will still retain all the values, all the important necessary information that is stored in the 30 features. So the second is aggregation and clustering. So in aggregation and clustering, we can remove the redundant features or the closely associated ones. That is the same thing as similar as to PCA. We can partition data set into clusters, and then we can store one cluster for representation only. We can only work on one cluster and then mathematically derive basically what will be the result for the whole cluster. And it can be very it can so can be very effective if the data is clustered, but if the data is not dirty. So as you can see, why after when we are applying data reduction techniques, you need to make sure that the other previous steps that Neeraj has discussed are performed well. So and there are various clustering choices and clustering algorithms, which we'll see. And the last method of data reduction is sampling. So suppose you have a really large data set, so we can choose to work on we can choose to work on a simple sample of a data set, and then basically test our results and test our model's accuracy based on that sample. And so basically what does a sample mean? It basically means a subset of the data. And there could be different type of sampling techniques. One first is random sampling. Random sampling is like we basically randomly choose a set of data, and then we start our we can start our data preprocessing and our ML model training and these type of methodologies to obtain an accuracy. And there is other method it's called stratified sampling. Here in this stratified sampling, we can suppose we have a normal over vote polling, right? So here we can divide the population into strata bases, like such as age, race, gender, identity, and location. And we can only test to collect polls for a certain location, and then basically enhance it to basically say that all the that all the that all the that all the basically as you can explain it more elaborately. Suppose you are basically testing a model of vote polling, right? And here basically what happens is, like in a state of UP, you can choose to select you can choose to select the polls for only a specific city, and then basically see whatever the specific city results in the model's accuracy will be the result of the poll. And okay, so we can basically approximate the sampling on the basis of the population of interest and overall basis. So now let's move on to our demo session, because we are running short on time. So so first we will be starting the data preprocessing techniques, and we will be importing our necessary libraries. So this is the data cleaning method. We are basically removing we are basically removing the duplicates. Here we have basically created a table that contains these type of brand styles and rating. So one of the methods we can use is df.dot duplicates. And so as you can see, after executing, we have basically dropped this one column. And so in this way, you can apply this to a similar bigger data set. This is just a simple example for your understanding. And we can also choose to do the raw duplicates method on a single column only. So you can see, we can do it by using subset is equal to brand, and we have only dropped the columns yum and maggie that is remaining. And the other is to remove the duplicates and keep the last occurrences. If you want, for some reason, if you want to keep the last occurrences or the first occurrences, you can choose to keep last and keep first, and it will not delete the it will not delete the last or the first occurrence of the repeated value. Now the second is handling missing values. Here what we are doing is we are basically importing our CSV file from a data set. Let's suppose it contains preg, class, and skin. Yes, column names. So, and this is our shape of the data. It contains 768 rows and 9 columns. And here, as you can see, what we are doing is there are majority of the values in the data set that contain zero values. So for the columns name class, press, skin, and mass, basically we so whatever wherever there is a zero, we know zero is not possible, so we have replaced it with none values. None is basically null. So what we can do is we can remove those missing values. So we can drop these features. So usually removing missing values in this type of data set is not viable. So basically, what we can drop the values. As you can see, after dropping the values from 768 rows, we have dropped it down to 392 rows. So as you can see, it could basically make our training data less viable. So our first method will not be doing this, but you can apply this also using the drop NA library, drop in a method. Now let's move on to filling the missing values with mean of the column. This is majorly done replacing with the mean value. So what we can do is rather than deleting all those columns and rows that contains the non values, we can replace it with the mean of the column, and we will be and then so as you can see, we can do it by fill na data frame dot mean, and by this we have replaced with the data frames mean, and we are calculating if we are basically calculating here if there is any null value remaining, so the sum is coming zero. So basically there is no non values and all the values have been resolved. So as we can see here, so all the values have been filled with the mean of the data set. The second is removing outliers of the noisy data. Let's suppose you have a normal simple data set of heights that contains some heights of some persons, and we are basically describing the data. As you can see, minimum maximum here, as you can see 40. So suppose the height is in feet, so there is no person that could be in feet. So this is why this is useful to see if there are some outliers. So one of the methods to detect outliers is IQR. So what does IQR do is like we calculate the Q1 Q2 range, basically the 25th and 75th percentile of the range, and what we do is we calculate the IQR by Q3 minus Q1. After getting this, we calculate the lower limit and the upper limit for the dataset that we are basically working on. So after
Ayush,
calculate, yeah, yeah,
I'm really sorry to interrupt in between, but it's already 5. So if we can please close the session.
yeah, sure. So as you can see, after finding the lower and the upper limit of the session, we have then we can apply the out DF method, and we have basically found out the outliers. And after removing the outliers, we can see the values of the outliers like 41, 2 are not present here. So one of the other thing is data aggregation, where here we are doing simply min, max, and median. We are finding out of the data set. So third is scaling. As I've told, scaling is basically putting the scale down to 0 to 1 or some ratio. Here we are using the min max scaler as I've discussed in the PPT. So here basically we are basically toning down the scale from in between the range of 0 to 1. Second is L1 normalization. L1 normalization is basically, as I've told you, see basically L1 normalization where some of the deviations will always add up to 1. So this is one of the methods we can use. And after normalizing the data, we will get these type of values. Second is L2 normalization. So L2 normalization is basically least of squares method. Here we can summarize the data, and after applying this, we will basically get the values in a certain similar way, but this will basically help us in improving our model's accuracy. The second is data reduction techniques. So as we can see, I'll try to make it faster. So as we can see, we have a data set that contains 30 features, basically. Contains 30 features, and as you can see here, 30 features and 569 rows. So, and after doing the PCA transforms, we have reduced those highly correlated features to 2. So as we can see, after reducing it down to two features, we can basically apply this to our ML models. And applying this, we can choose our classification algorithm. So to basically detect, to basically improve the model's accuracy and detect whatever we want to predict accurately. Second is the last one is sampling. So sampling, as I've told you, we can basically choose some subset of the data s- data and then perform experiments on. We can choose to perform experiment on that data set only. Here we have only chosen the 25% of the data set, and it is randomly chosen. So that is it for the data preprocessing session side. If you do have any doubts, we are free to you are feel free to ask to Neeraj and me. We are both available. Okay. Do we have any doubts?
If not, then uh, get Pranav.
No, I was just going to say, yeah, it was a good session. Yeah, thank you.
Thank you,
And
Pranav.
that depiction of the supervised and unsupervised learning.
The references that you took that really connects.
Thanks, Durgesh. Thanks, Pranav.
Thank you guys.
Okay.
So if not, then thank you guys for attending the session.
Thank
And
you.
then
Thank you guys. Bye.
Yeah. Thank you, everyone. Thank you.
Thank you.